Yo, what's good everybody? This is Mr. Roger, and in this video we're going to explain the difference between a pressure switch, a safety draft limit switch, high limit switch, and our rollout switches. All of these switches are safety mechanisms built into the system to make sure that everything is running properly in order to ensure safety on the equipment. The main purpose of our pressure switch, which that's what this is right here, you can see that there is a tube going from our pressure switch to our inducer motor assembly or inducer assembly. And what this does is this closes to verify that we are inducing a draft. When this motor is spinning, it is pulling a small tiny vacuum on this pressure switch, and when this pressure switch closes, it then lets us know that we can proceed to the next process in our ignition sequence. So anytime that your furnace comes on, calls for heat, your inducer motor is going to kick on. That is the first step. It's going to induce a draft. It is going to pull a small vacuum. Pressure switch is going to close. It's going to signal to our furnace that we are ready for ignition. Next step, igniter is going to kick on, gas valve is going to kick on, flame's going to prove, and if everything looks good there, then the system can run normally. This switch right here is a draft guard limit switch. You notice that it's actually on the exhaust itself, the flue piping itself, and the purpose of this is to ensure that your flue gas pipe does not get too hot, because that can cause issues with overheating. So Carrier and some other brands, you'll typically see a draft guard limit switch here in order to detect overheating at the actual exhaust piping out that's going outside of the house. The next switch that you see right there, that is our high temperature, high limit switch. That switch right there is going to detect the heat in your heat exchangers. So for instance, if your blower motor is dead, there's no airflow going across, or you have a clogged evaporator coil, or maybe you have a cracked heat exchanger causing the system to overheat, that temperature limit switch is going to trip in order to shut the system off to prevent the system from overheating. And for this switch and that switch there, you can see that it doesn't have a little tab on top of it like that. That is because those are automatic reset switches, meaning that once they trip and the temperature drops below the threshold set by the manufacturer, they will automatically reset. The system will go back to normal operation and it will try to run it again. This switch right here, you notice there's a little button on top. This is a manual reset flame rollout switch. That switch right there, the importance of that switch is to ensure that the flames aren't rolling out, causing this section of our burner compartment to overheat. Typically when you have a flame rollout switch tripping, there could be gas pressures that are bad. There could be a numerous amount of things, maybe a cracked heat exchanger causing this area to trip, maybe poor gas pressure, maybe you don't have enough gas pressure to go inside the burner tubes, going into our heat exchanger, maybe the crossfire tubing is bad. I don't know, there could be a lot of different reasons that could cause a flame rollout switch to trip. And all of these safeties, in order for this system to work properly, every single one, that one, that one, that one, and that one, they all have to be working in order for this furnace to operate correctly. So now that we understand the gist of how these work and their purpose, let's go ahead and go into how to test them. In order to test these switches, the easiest way to test them is through continuity. And what we're doing when we test continuities, we just want to check to make sure that there is a straight path of contact between point A and point B. And if there's any breaks in the lines, then we're not going can be receiving any continuity. So this unit's functioning and our pressure switch is functioning. So the easiest way to test this would just be to pull this back a little bit so we can expose the terminals and stick our meters in there. And as you can see, we are receiving continuity. So that means that this is functioning perfectly fine. I'm gonna go ahead and remove this hose here, and you're gonna notice that we lose the continuity immediately. So now we have continuity, and now we don't. And now the furnace is off because this is a safety mechanism. So anytime that this pressure switch loses vacuum, we are no longer gonna have ignition. The furnace is gonna go into a lockout. It's gonna go and try again once it reaches its timer. And that is how these pressure switches work. That's how it's tested. Let's go on to the flame rollouts. So for the draft limit guard switch, you're gonna do the same exact test. And you're gonna check continuity. Because this is an automatic reset, if this does not have continuity and it's been off and everything reset, then you know that this is gonna be potentially bad, or it's open and has overheated. This should automatically reset once the temperature reaches a specific temperature range that's below what they set from the manufacturer. And the same exact way that you test this switch is going to be the same exact way that you test the high limit switch as well. And that also goes for that rollout switch as well. The only difference on your rollout, on your flame rollout switch, is that it's a manual reset, and if it trips, you are going to physically have to go in, press the button down in order for it to reset. And then that's when you'll go and do your troubleshooting into figuring out why any of these rollout switches tripped. Hopefully this helps you out, guys. Please look me up on my other platforms. You already know what it is, baby. Let's go.